Hello, my name is Nagasai Purvach, and today I am going to talk about the Internet of Things for sleep monitoring. The Internet of Things, or IoT, is a platform which is used for many applications. Like it is used in many applications in which the hardware is connected with the software and used it. Introduction: we have to know what is a sleep monitoring device. Why we have to monitor the sleep in the first way? In the broad spectrum, the sleep is related to brain activity, and the brain activity here is the brain exhaustion. The sleep quality determines the good mental health, minimize the fatigue of the daily routine and sleeplessness, which leaves a positive impact on your body. Any disruption in the sleep cycles results in the poor physical health, and various internal and external factors contribute to sleep abnormalities. Like mostly it is going to be mental and psychological and biological factors, and it also causes the sleep illness trigger. It also called as illnesses, and it also more causes anxiety and depression. So we can see that now we know why we have to monitor the sleep. We have to know how can we monitor the sleep, like how are the different ways we can monitor the sleep. There are, let's say, we can monitor the sleep by using autonomic signals. Like autonomic signals, the signals which are passed through like on a bed, on an observation in a patient body. Then we can use the brain activity by using some high frequency wearable devices on your head and everything. Then movement based devices. If you are moving around in your bed so much at night, we know that you are not a good sleeper. Then we can use the bed based, where we can use different sensors around the bed, and we can monitor the sleep of the user. Then let's say these sensors are used for sleep staging, and this is called as polysomnography, in which the type of sleep is observed in the technology, where we can mostly use like breathing, temperature, muscle fatigue and oxygen saturation, or SpO2. With the help of these technologies, the researchers can determine the sleep onset and wake up time. A device, let's say nowadays there are many devices like your smartwatches or sleep tracking devices, devices which can be attached to the wrist of the patient during this sleep to analyze the physical parameters or changes. It investigates that there is solid relationship between the wrist movement and sleep status of the user. In the other method, we can also use audio video recording together with the PIR sensors to determine the patient's sleep status, and we can also determine the ambient observation, in which the PIR sensors are used for the motion detection and interaction which are connected to the windows and doors to check whether the environment is good, where we can detect heat and energy of the whole environment which we are sleeping. These are the different parameters we have to look around for determining whether a person is sleeping good or they are having any problem sleeping. Now we have attached the premise how we are going to do, and why we are doing, and how we are going to do, and what are the different things we can do. Now the proposed system is most likely this, is that we are going to sense the movement, we are going to sense the heartbeat, we are going to sense the SpO2, and we are going to sense the breathing, and we are going to give the system to something. It can be anything, and we are going to use the random forest model. I am going to explain afterwards why we are going to use random forest model afterwards. Now we know we are going to use these types of sensors, and there are different easiest method we can explain it through by using an example system. I'm going to use an example system with an Arduino. Now the example system for the Arduino is that we are going to have two different types, which is environment setups. In environment setups, and we are going to use an accelerometer for detecting the movement. We are going to use the pulse oximeter for detecting the heartbeat and SpO2. Then we are going to use microphone to detect the breathing. These are the three things which we are going to use to determine the water. And this system, we are going to send this recording input or the Arduino which is connected to these sensors, and these sensors are going to send the data to Arduino, where the data is converted from the analog data to the digital data, where we can use the data in some form, and we are going to record the data in the computer or anything which we can use, and we are going to use the random forest processing. In the random forest processing algorithm to determine whether they are sleeping good or not. Now now we know why. You may ask why we are using this particular sensors. Let's say ADXL 345, which is a accelerometer which is used in many applications. In this particular case, the accelerometer is used for detecting the movement, and the ADXL accelerometers are the perfect accelerometers because we can use the ADXL accelerometer to determine the smallest movements of the smallest movements, and pulse oximeter max 30 is used in most of the cases because it is easier to use with Arduino, and we are going to use max 98 because it has automatic analog to digital converter in it. So now we have known. Now we are going to take the data and convert it into digital form. We are going to split the numbers into the algorithm or computer, and the computer determines the output and visualize. We are going to visualize the results in mobile or anything. Now why random forest algorithm? The random forest algorithm is a supervised algorithm where we have to use the different instances and attributes to determine what is happening in the algorithm. So they are going to take the instances and attributes of the data and train the data. We have to train the data in the supervised learning. And why? Because everyone has their own sleep patterns. Every human being have their own sleeping patterns. So we have to learn. We have to know how are we going to determine they are good sleeper or not. We are going to use different model building patterns, and supervised model is used for evaluation. Now the random forest algorithm works on the voting system, in which the outlook model or the model takes the different votes from the model parameters and determine whether the generated data is good or not. In this case, I have taken the temperature data, in which temperature data or weather data, and we know that if it's sunny, it's going to be humid. It can be high or normal. If there is an overcast, we know that it is going to be overcast. Then if it's rainy, we know that it's going to be slightly windy or weak, more windy or weak. These are the different words we can use to determine. This is the random forest algorithm. Now we have to take the training set data and train the sample data, and we have to get the decision tree 1. Now let's say what is our decision tree 1. In the decision tree 1, we have taken the movement. In the movement, we know that at the night, if a person is moving a lot, then there is some activity that is wrong for the sleep cycles. We know that when we sleep, we are going to go from different stages of sleep. So if we go from normal sleep to REM sleep, we are not going to move at all. So we are going to take the movement data, that is our first decision tree, and we are going to take the test set in which we are going to record some of the movements of normal sleeping people, and we are going to determine they are normal sleepers. Now next we are second decision tree for us is the heart rate monitor and oxygen meter. The oxygen meter and heart rate monitor, we are going to determine in the same way we are going to train the model by people who have normal sleep, their heart rate and SpO2 level, and determine the decision tree, and we are going to have the same tree. Now we have generated the model which can work on the algorithm, for the voting. Now the voting system can be done and completed. Now voting system is done and completed. If let's say a person is sleeping, if he had more movement and he has more amount of heart rate and less amount of SpO2, then he is not sleeping well. So we are gonna vote and predict that he is not a good sleeper, and we are gonna determine whether he is sleeping, how much amount of sleep is he getting, using different data voting sets. Now let's see how the patient's sleep quality results. There are people, this is the people's block. In the y-axis, this is the number of people, and this is the number of predictability. In the medium level, he is using this is the level. In the voting system, we are going to generate some amount of voting level, and the voting level is this thing. We are, let's say, in the medium level, he is going to sleep for 150. Parameters, 150. Then in the peaceful level, he is going to sleep for 450. In the unpeaceful level, he is going to sleep for again 150. And in the very peaceful level, like he just sleeps, then he is going to be for 0. He is going to go for 0. This is very important, that because of this outlier, we are using this random forest generator because of this outlier. Then is the very unpeaceful level. These two are the outliers in our data sets. That is why we are going to use random forest generator. Random forest generator does not have any if you want to use the outliers, we are going to use another decision tree for those outliers. That is why it is easy to determine the random forest generator. We are going to use the very by using this analysis, we can see that the patient is good at sleeping or not. In the conclusion, we can say that it is very cheap and it is useful, and we have many different sensors and Moreover, the computer system is most robust system, and it is used in many applications. And although the random forest classifier method has highest amount of classification, it is the most robust classifier. So we are going to use those classifiers to determine it has highest level of accuracy of 95%, and the proposed methods are useful for any applications in the sleep monitoring systems. And the portable sleep quality can be proposed through wireless sensors and microcontrollers, and we can even use Raspberry Pi and use the system for the mobile app too. And thank you.